Hey guys, welcome back to my channel. So in the last video on linear classification, we talked about negative log likelihood loss, and we directly used the gradient equation of this log with respect to W and B to optimize the loss, right? And there we discussed that in the next video, we'll do the derivation of how do we reach to that gradient equations. So in this video, we will do exactly that. The only property or result that we'll use here is the derivation of the sigmoid function. So if you calculate the derivative of the sigmoid function, it has a very nice property, which is that the first derivative of the sigmoid function is equal to the multiplication of the sigmoid function into 1 minus the sigmoid function, right? So this is a very nice property to have, and this is something that will make the calculations very easy for us. So just a very small recap, the linear classification equation that we discussed was basically y is equals to w times y is equals to wtx plus b. So this is your output also, right? This was the output that we were using to predict, and the sigmoid function was basically a non-linear function that sort of has value between 1 and 0 and crosses the y-axis at 0.5, right? So this was the sigmoid function. So now this is the loss equation that we used in the last video also, and this is something that we'll now use to derive the gradient equations. So let us get started. So let me pick this part of the equation. So what we have to do is, this is the loss value, so we have to calculate the loss with respect to W and with respect to dB, right? So the way I will do the calculation is, O here is the linear equation, right? So this is the linear equation that we want to calculate on. So what I'll do is, I'll keep O as it is, and then finally when we have a combined derivation, we will substitute the derivative of O once with respect to W and once with respect to B. Okay, so let us get started. So if you do the derivation of derivation of this, it will come as minus y. Derivation of log x is 1 upon x, so log of sigmoid is 1 upon sigmoid, then derivation of sigmoid, and then derivation of the function minus 1 minus y. Again, derivation of log x is 1 upon sigmoid, derivation of 1 is constant is 0, minus sigmoid of O is minus sigmoid dash of O into O dash, right? So now if you simplify this further using this property, this will come as minus y into sigmoid of O into 1 minus sigmoid of O into O dash upon sigmoid of O minus 1 minus y negation of sigmoid of O into 1 minus sigmoid of O into O dash upon 1 minus sigmoid of O. Now you can cancel few terms, so sigmoid of O cancel here, and 1 minus sigmoid of O and 1 minus sigmoid of O cancels here, right? So further reducing this equation will become minus y 1 minus sigmoid of O dash. Now this negation and this negation will become plus, so this becomes this O dash, right? Now here O dash is common, so you can take everything out, so it becomes minus y 1 minus sigmoid of O plus 1 minus y to sigmoid of O complete O dash, right? Now expanding this equation further, this will become minus y plus y times sigmoid of O plus sigmoid of O minus y times sigmoid of O. So if you simplify it further, this cancels out. So let me use this part of the page. So if you further simplify, this becomes your sigmoid of O minus y to O dash, right? So this is because this is your derivative of the loss function. Now O, as we discussed, is W times Tx plus B. So O dash with respect to W will basically be x, and O dash with respect to B will basically be 1. So now if you want to calculate O dash for respect to W, So the derivative of the loss function with respect to w will be sigmoid of O minus y into this value, right? So 2x. And similarly, the derivation of the loss function with respect to b will be sigmoid of O minus y into this, which is 1. So these are your gradient equations which we use. You can go back to the last video and see that these are the exact equations that we used in a last video as well. So I think this is it. Thank you so much for watching. Do not forget to like, share and subscribe to this video. And the next video that will come, it will talk about gradient descent. So do not forget to watch that as well. Thank you.